if A is a square matrix, is orthogonal as well as symmetric, then first option is A is invaluatory matrix, B A is idempotent matrix, C A is diagonal matrix, D none of this. So this question was asked in PGCET 2020. So this is a 1 mark question. So let us see how to solve this question. So before solving this question, let us understand the meaning of some of the terms given in this question. Solution. So first we should know what is orthogonal matrix as well as we should know symmetric matrix. So to know the meaning of symmetric as well as orthogonal matrix, first let us understand the meaning of transpose of a matrix. Transpose of a matrix. So transpose of a matrix means in any given matrix, if you interchange rows and columns, we call it as transpose of a matrix. Suppose example, consider A as the matrix with elements 1, 2, 4, 5, 6, minus 7. So this is the matrix A. So transpose of the matrix A is denoted by A power T, or we can denote like this, A dash. So these are the notations used to denote the transpose of the matrix A. So how to obtain transpose of the matrix? As I told, we have to interchange rows and columns. So this is the first row, 1, 2, 4. So we have to write first row as first column, that is 1, 2, 4. Similarly, we have to write second row as second column. So 5, 6, minus 7, we are going to write like this, 5, 6, minus 7. So that is, we are interchanging rows and columns of the matrix to obtain the transpose of the matrix. See here, order of this matrix is 2 by 3. So it has 2 rows and 3 columns. So order of the transpose of this matrix, it has 3 rows and 2 columns. So order becomes 3 by 2. So in general, suppose A is any matrix of the order m by n, then transpose of the matrix is of the order how much? N by n. So this is the meaning of transpose of the matrix. Next we are going to see what is the meaning of symmetric as well as orthogonal matrices. Now let us see the meaning of symmetric matrix. So for any square matrix, suppose A is any square matrix, if A is equals to A transpose, if A is equals to A transpose, then we are going to call A as the symmetric matrix. Example, suppose consider the matrix A is equals to 1, 5, 5, 6. As I told, find the transpose of this matrix. So transpose means we have to interchange rows and columns. So 1 and 5 are first row. I am writing first row as first column. Again, second row as second column. So if you see these two matrices, both the matrices are same. So clearly we can say that A is equals to A transpose. So this is the example for symmetric matrix. So let us see what is meaning of skew symmetric matrix. So skew symmetric matrix means if A is equals to minus of A transpose, if A is equals to minus of A transpose, then we are going to call A as skew symmetric matrix. Suppose consider A is equals to, consider the matrix 0, 2, minus 2, 0. This is the matrix A. If you take transpose of A, that is A transpose is equals to, so what we are going to do, we have to interchange rows and columns. So 0, 2 I will write as first column, minus 2, 0 as second column. So this is A transpose. Suppose if you take minus of A transpose, so minus of A transpose means I have to multiply each element by minus. So this will be 0. Minus of minus 2 becomes 2. Minus 2, 0. So if you see these two matrices, A and minus of A transpose, both are same. So here in this case what happens, A is equals to minus of A transpose, then we are going to call A as skew symmetric matrix. You should know the meaning of symmetric as well as skew symmetric matrices to solve the problems on matrices. So now let us see the meaning of orthogonal matrix. So orthogonal matrix means a matrix is said to be orthogonal if A into A transpose is equals to A transpose into A, that is equals to identity matrix. If you multiply any matrix A with its transpose, if you get identity matrix, then we are going to call it as orthogonal matrix. So or what we can say, we can write A transpose is equals to, if A transpose is equals to A inverse, if A transpose is equals to A inverse, then also we are going to call the given matrix as orthogonal. So one condition is either A into A transpose is equals to identity matrix, or if you rewrite this one, what we can write, A transpose will become A inverse. So after that we have to see the options. So A is invaluatory matrix. So invaluatory matrix means so a matrix is said to be invaluatory if A square is equals to, if you get identity matrix, so if you find A square means multiplying A with A. So if you get identity matrix, then we are going to call the given matrix as invaluatory matrix. Second option is idempotent. Idempotent. So again a matrix is said to be idempotent if A square is equals to A. If A square is equals to A, then we are going to call that matrix as idempotent matrix. Third option, diagonal matrix. So diagonal matrix means a square matrix in which all non-diagonal elements should be 0. Suppose consider a square matrix of order 2. Suppose 1, 0, 0, 2. So if you consider this matrix, so what happens? So this is the diagonal elements, or we can call it as principal diagonal elements. So other than these principal diagonal elements, all other elements are 0. So this type of matrix in which all the non-diagonal elements are 0, we are going to call it as diagonal matrix. So fourth option is none of this. So let us find out the correct option. So they have given, what they have given, it is orthogonal matrix. Since orthogonal, what we can write? So since it is orthogonal, I can write A into A transpose is equals to identity matrix. Second one, as well as it is symmetric. So from the definition of symmetric matrix, so symmetric matrix means A is equals to A transpose. So if you see these two equations, so what we can conclude? So in the first equation, A into A transpose is equals to identity matrix, that is A into A transpose. In place of A transpose, what I can write? A, because it is also symmetric matrix. Symmetric matrix means A transpose is equals to A. So in place of A transpose, I am writing A. So A into A is equals to identity matrix, or A into A becomes A square is equals to identity matrix. So A square is equals to I. A square is equals to I means what we are getting? It is a invaluatory matrix. So the correct option is first one, A is invaluatory matrix.